All right, so we're rolling again. Another thing, anybody ever read the book, The Mythical Man Month? In there they gave an analogy that says 9 women cannot work together for 1 month and create a baby, right? That's kind of a similar concept to what you're talking about here. Things that you think extrapolate linearly, like a bridge, for example. If it holds up at 10,000 and 50,000 kilograms, I know that everything in between is also going to work, not so with software, right? Solutions in search of problems. Ever get one of those sore throats? And when I say sore throat, I mean one of those ones that feel like you swallowed a cat, and it extends into your ears and your whole head hurts. When I go to the doctor, you know what I hope they're going to say? I hope they're going to say, Chris, you got strep. You know why I hope it's strep? Because you can cure it. They can give me the Z-Pack. Okay, they can give me the antibiotics, the erythromycin, the whole 9 yards, and within hours I start feeling better. Okay, even though you got to take the whole thing, right, to make sure you get everything, but it slams the bacteria pretty quick. Okay, but you know what the bad news is? Chris, it's a virus. No! Just take ibuprofen, you'll be fine. No, give me the Z-Pack anyway, right? It'll make me feel like I'm doing something. Well, no, but you don't have a bacteria. I can't cure a virus. Well, even though the symptoms are the same, right? Many times in performance, symptoms will mimic something else when the problem is really something different. Yet, it's human nature, okay, to try to solve the problem in a way that meets your specialty. It's the analogy of whoever, is an expert on a hammer is going to try to make every problem look like a nail and is going to try to solve every problem in that manner, okay? So, for example, what is the biggest, there's a lot of areas in which this is a problem, but database indexes, probably the worst. It's not going to help a performance problem unless the time is being spent on a slow query which is in need of that particular indexes. What you find is some folks will try to just add indexes, okay, just because an index suggester says, well, add this, this, and this, but without having a specific reason for each index, okay? There are no mystical properties of indexes that make things faster. They are to support particular queries and particular structures and make them faster, okay? But indexes add disk space. They will increase the response time of inserts, updates, and deletes. They can confuse the optimizer if you have too many of them. It's a bottoms-up sidetrack, in other words. You should arrive at an index by getting there through top-down analysis. Somebody hits the find button, boom, it's slow. Okay, where is the slowness? It's in this particular query. Why is that query slow? Well, it might not be because of an index. It might be because it's poorly formed. It might be because it returns a ton of rows, and no index will help it because it's going to scan anyway, no matter what. On the other hand, you might go through all the reasons the query can be slow and then discover that it is an index opportunity, okay? But it's a full-time performance engineer, who needs to figure that out, because oftentimes people are in their silos, and don't understand the big picture. Where is the code spending its time? By the way, why is Hank Aaron on here? Hammer and Hank? Oh, well. So, accurate use cases, okay? You can't find out who broke into Safeway in Denver by looking at a security tape from a Safeway in Fargo. Okay, seems pretty obvious, right? Okay? But you need the tape not only from the same Safeway store that got robbed, but you need the tape from the correct date, from the correct time of day, and the correct part of the store. All those things have to be correct, otherwise you won't catch the thief. Even if you got 9 out of 10 things correct, if it's the wrong part of the store, say, the evidence is no good, won't tell you anything. What that means is, in the software world, you have a fairly low margin for error for defining the problem. If one small detail is wrong, okay, it'll lead you astray. It will lead you to places and it'll lead you to solutions that aren't the solutions you're looking for, okay? So my point is here, you can't analyze a problematic batch program using any old profiling log, generated any old time by any old data set using any old set of runtime parameters, simply because the same batch program was used to generate the log, okay? And I have people do that all the time. Consultants, customers, well, can I get a log of this? Well, here's a log we generated once, sometime last spring or whatever. Am I getting a little bit of feedback there? So, any event, you need a profiling log generated by the correct application and version, the correct use case, the correct configuration, the correct platform, database, etc. So the problematic performance issue must be reproduced when the data is collected. It's, again, a little bit like trying to simulate the effects of rocks on a windshield by using marshmallows instead of rocks. They're about the same size, they're about the same shape. I can even spray paint and gray, so they're about the same color, but is that going to give me a valid test? No, but I got almost everything right. I got the size, shape, color, and all of this stuff. Doesn't matter, they're marshmallows, they're not rocks. Hopefully you can figure that out, okay? Why that's not valid? Bad tests are worse than no tests at all. You may as well not do them, save time. Make up answers, okay? You do a Bernie Madoff test, just make the numbers up. I'm being facetious here, but seriously, just not and say you did, because it's just basic, it's garbage in, garbage out. Okay? If your use case isn't accurate, then you will not be testing performance, and you won't be finding the real problems. Do not duplicate, okay? If I'm sick, I can't send a twin brother to the doctor to find out what's wrong because I don't want to go to the doctor, right? Doesn't matter. I'm sick, he's not. And maybe he's across the country someplace. You know, whatever, he's not even close to me, okay? I mean, if I break my leg, I can't have my brother treated. I can't have my brother examined and x-rays. Okay, remember those Doublemint ads from the 70s? Remember they always used to show two of somebody? You'd find all these identical twins and have them be in the ads. Anyway, it's the same thing in performance, okay? Ever hear the infamous, let me duplicate your issue, you know, over here at the help desk? Well, performance issues, you know, are something that on a production system, they've got different data, they've got different machines, they've got different networks, okay? One small detail being missed can mean an entire code path is being missed, okay, and you'll miss the problem. Okay, if anybody's ever shot a rifle, a range, say a 200-yard range, and you're shooting a high-powered rifle, your target, base of your crosshairs covers the entire target, okay? And if you move the gun a fraction of an inch from where you sit, 200 yards away, that translates to 2 feet, and you miss the target entirely. Okay, another way of thinking of these things, that if one small detail is missing, you will miss the problem. So if you try to duplicate a customer's environment, try to clone their environment, if you will, you can miss the problem entirely. Here's a quote from one of our customer support managers, and it says, the interesting thing about performance is the sheer number of influencing factors that can cause even savvy developers to make wrong choices. Customer-specific data, indexes, user behavior, rows and table, database optimization, speed, machine speed are all factors other than code, okay? So the bottom line is you need real data from a customer environment done on their premises with their use cases, okay, to be accurate. And what this implies, usually, is that the customers have to have a test system which mimics their live environment on their site. In my opinion, this is not a luxury. Well, that's expensive. We can't afford that. Fine, but you better be able to afford the downtime of your live system then, if something goes wrong. Or you got to be able to collect downtime in the live, you better be able to collect data in the live environment, which, by the way, is not always impossible, depending on the nature of the problem, whether or not you can isolate the generation of debug data and log, which can be intrusive. You can't do that. This last statement is not necessarily facetious, but it doesn't always work, right? So again, if you can't afford a test environment, you better be able to afford downtime. You better be able to afford that. Okay? Performance first principles. Okay? You cannot pass a college-level open book exam by memorizing facts. Anybody ever have an open book exam in college? If you did, you know one thing, you don't want that. Okay? Why is that? They can ask anything. Anything is on the table since you have all the reference in front of you, right? Not to say that memorizing some of the key facts so you don't have to spend time flipping through pages is helpful. It helps streamline the process. But the facts are part of the process, okay? They don't replace it. That's why performance, again, you don't execute performance analysis starting with a top 10 list, rules of thumb, anecdotes, even though this is what I get asked all the time. The reason is you're not going to be able to interpret those principles and anecdotes in the proper way, okay? Because a single action item from one of these lists might seem to fit a certain situation, but might not represent what the time is being spent, right? So in other words, somebody might say, okay, buffered inserts is a great way to improve performance. This batch application has inserts, okay? It has a lot of inserts, so I'll just put buffered inserts. But it's going to take me a week of coding effort, blah, 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 QA testing. Well, what if only 3% of the time was spent doing those inserts? The reason you got that wrong and that effort was kind of wasted is because, okay, you didn't understand first principles. I got to know where the time is being spent so I know which one of these top 10 list items in order to apply. It's kind of like, well, if you put an object in water, it displaces water, right? I can prove that in a bathtub. Okay, I can overflow the bathtub, whatever. I get in a full bathtub. So to solve the problem of ocean levels rising, don't have people swim. Because if everybody in all the beaches of the world would get out of the water, then the levels would drop, right? That might be technically true, but it is irrelevant, okay? You have to understand first principles, the scale involved, and whatnot, okay? Every performance situation is different. And what I've found, too, is to solve these issues, you need help. I know I can't do it myself. I mean, sales order entry, well, that's kind of like the app I use when I order stuff from Amazon.com, right? Something like that. I mean, I know enough to be dangerous, and barely that. Subject matter experts includes application developers from both the tools and the app side, DBAs, business analysts that understand how this thing is being used, okay? So what I say here in terms of my takeaways, tips are for waiters, analysis is for engineers, technicians read from the list created by engineers, and if you're a technician, you want to become an engineer, add new items to the list, okay? You become an engineer when the top 10 list becomes the top 11, okay? Who's going to add number 11 to that list? To streamline the process of where's the code spending its time even more, okay? So next, moving along to all CPUs wait at the same speed. Going with our car analogy again, this time turning it on its head a little bit. If I want to get to work faster, okay, I can't just buy a faster car. Well, geez, I can buy a Maserati for $300,000 and it can go 180 miles an hour, which is 3 times faster than my little beater car will go. So my commute of an hour now gets reduced to 20 minutes, right? Just doing the simple math, the numbers work out, right? Doesn't exactly work that way. Okay, forgetting the fact you got stop signs, traffic lights, fines, jail time and whatnot, limiting my speed. Even if that weren't the case, what if there's traffic? Then I'm going to be just a fast car right in traffic, right next to or behind all the other beater cars. It doesn't matter that I got a faster car. I can't make it go faster if it's stuck in traffic. Okay, that's just a simple fact. And in the performance world, heck, I've seen desktop PCs that will run certain batch programs faster than a server-class machine. Okay? The reality is response times and run times have many possible causes, and many of these are not a function of the size of the machine or the speed of the CPU. Okay? If you've got contention issues, row locking, transaction processing issues, long-running SQL, all of these things block the program. I can't make a piece of software wait faster. Okay? I can't make software do nothing faster. CPU's speed only impacts running code, not waiting code. All right? So if a program takes a long time to do something, okay, because something isn't running or nothing is happening, doesn't matter that I spend all the money in the world, the biggest machine in the world that isn't going to address the problem. Okay? So performance analysis is not done on paper. Okay, you wouldn't fly in an aircraft that's been proven to fly only in paper simulations. Unless you're this guy, you know. The great Chuck Yeager had the right stuff. That's what he did for a living. He was a test pilot of planes nobody'd flown before, okay? That's great, but I don't know if that's what I want to do. I don't know if that's what you want to be into either. Bottom line is performance analysis is not static analysis of code. Performance is inherently a dynamic runtime activity. It's not done by reading code alone. Not that reading code doesn't give you context and maybe confirm some of your assumptions in your analysis, but the bottom line is the human brain is like a computer. You know what speed it runs at? About 27 hertz or so, give or take, is what I've heard. Now, why try to run a piece of software that was meant to run on a multiple gigahertz machine with a 27 hertz computer? Because that's what you're doing when you try to simulate code and all the machinations and all the complex things that can happen when you hit return. It's just simply not a predictable thing. Chaos theory applies, right? You don't know all the interactions, everything that's going to happen unless you just run it. There's no way of predicting it without running it, okay? And, you know, this is where I've got a quick little case study here, or at least the punchline from a case study. We had a modification to a batch program at customer. Customer did their own customization to one of our standard pieces of code, and it resulted in greatly reduced throughput. We had a consultant research the matter and said a significant modification was made, but apparently it caused major timing differences. And the modification that was made was the select was selecting the same number of columns, but one of them was changed. An order number was the old change, and then the new select selected on invoice number. But the thing is, there can be many, many orders for the same invoice number. So there's a great big fat one-to-many relationship that's going on here. DOCO to DOC. Those are our weird J.D. Edwards abbreviations for some of these columns. So that caused a piece of C code to iterate many, many more thousands of times than it did before, just because there was a slight modification. This is a quote from the consultant. Said, "I'd left this code alone in my first round of remediation, changing the code. And by the way, the remediation involved only static reading of the code. Oh, this looks good, this looks good, this doesn't look like it's going to cause a performance problem, blah, blah, blah." Okay, well, it's easy to see that here. Okay, it's easy to see once after the fact, Monday morning quarterback, that this is going to cause all these thousands more rows. But how could you see that by reading the code the first time if you didn't know that? I wouldn't. Oh, well, you got this select here, this line of code here. It's one little change, but it resulted in a batch program running many, many times slower because it generated many, many more iterations in one loop, okay? And on the other hand, I've seen code changes that have involved a lot of lines of code that haven't been very intrusive, okay? So again, it's the Kierkegaard quote is down here. Life can only be understood backwards, but it's got to be lived forwards. Okay, you've got to run code to figure out what's going on. So the whole is not equal to the sum of the parts. If I light a match that's in a room that's full of 2 parts hydrogen and 1 part oxygen, boom, right? On the other hand, if I pour a bucket full of hydrogen and 1 part oxygen onto the resulting fire, poof, Okay? It's funny how the same exact amount of chemical elements can do very, very opposite things once they're somehow combined, right? That's the same thing in software. What I say is the one factor at a time principle applies here. It's a fundamental QA concept that applies to not only functional analysis, but to performance as well. Software is just wrought with these complex interactions that are neither intuitive nor obvious, just like our static analysis example from earlier. Code changes are not mutually exclusive. You can't assume that two changes will reliably add in a linear fashion. You can have one modification cancel out the effects of another. Exhibit A on that. Okay? We had a problematic batch program that was run typically as 10 concurrent jobs to process its data. We profiled the job, we made code changes, the code changes removed huge sections of the code. And we knew it reduced the CPU cycles considerably in order to process each piece of data. However, once we ran this thing, it ran in about the same amount of time. Okay, the same 10 concurrent job set, even after we made these changes, which we knew reduced the CPU. So what's going on here? What's happening? Well, this was due to the interaction of two different factors, which we didn't anticipate. These four vertical bars here represent, as time goes on, the four different jobs. What's written here is I/O, or database I/O. And before we made the code change, because there was excess code cluttering this runtime, we had the I/O across all the four jobs was kind of separated, and the probability of locking or seizing conflicts in the jobs really wasn't there as much. It didn't happen as often because it wasn't as likely to happen because, the I/O was separated. However, once we made each job, more compact in terms of what the CPU did, now these I/O were more closer together, and there was more probability of these jobs, conflicting with each other, and that created a certain type of a lock called a seize lock that you get on the IBM iSeries platform. And with this, these seize locks, from a time standpoint, pushed the jobs right back up part again. But instead of because of CPU time, now it was because of wait time. Okay, now again, something you can't predict and you can't see ahead of time unless you actually run the code. About 10 minutes. Right, thanks. We ought to be in good shape. Discovering Pluto. The way Pluto was discovered, and I guess it's not a planet anymore, but that's a whole different ball of wax, whole different discussion. But there's a fellow named Clyde Tombaugh who used a clever device called a blink comparator. And what it does is he was comparing star fields one to the other, and he had basically a device that showed the two pictures together, and you kind of blink your eyes and see what's different between the two. Okay, what moved? It was a device that could show you in an otherwise very bland and meaningless star field what was going on. Did something move, one day compared to, 5 days later or whatever it was? And that's how he knew there was a planet that was much closer than the fixed stars, because otherwise everything's just points of light. Now, when a software performance problem is attributed to a version upgrade, some change, some before or after, incident where I applied a patch, everything slowed down. Okay, and then what people do is often they'll give me a profile from the after case and say, find what's wrong. Well, the problem is, I don't have in my head a picture of exactly what every use case in our entire product is going to look like. Okay, it's going to look, if you give me a profile, it's going to look as bland as a star field. Only the comparison is going to make it obvious. So the case study here is, here's a batch job that exhibited a decreased throughput following an upgrade to a new version of the code. This is what I call a baseline degradation issue, not an intrinsic opportunity. A single code profile is just going to look like a star field. I mean, I know where time's being spent, but I don't know what's abnormal about it, okay? Usually it's simply not going to jump out at you. And what we did here, by the way, is we took data from the iSeries they have a tool called PEX Performance Explorer that generates data. We wrapped a little MFC user interface around it that we can quickly sort and analyze this data, and building your own tools is something I recommend. We've got the resources to do that, by the way. But we needed a before and after comparison against a baseline. And what we did is we wrote a simple C language difference engine that processed the two code profiles, compared the two, and highlighted the differences. And after we did that, we found a fairly obscure cache-init API that was called the same number of times, but for much more time. Okay, so it narrowed down the problem to one obscure API way down on the call stack. Okay, but we wouldn't have found that just by looking at one profile. It's kind of like our blink comparator. That's what this is. You take one profile, you take another, boom, build the difference engine between the two. All right? Database size matters. Recipes, right? Anybody who's ever baked, especially, recipes are nonlinear instruments, aren't they? To double a cake recipe, you can't reliably just double all the ingredients. Like things like baking soda, baking powder, these are nonlinear type characteristics. Spice, cooking time, the altitude you're at, we're in Denver, okay? I made some pumpkin pies this Thanksgiving. I used twice as much cloves as the recipe called for. Now, as it is only a little bitty quarter of a teaspoon of cloves, but the stuff is expensive. You buy a little jar of cloves, it costs like $9. Like, what's in it? Gold, mixed with the cloves. But in any event, even an extra quarter of a teaspoon across 2 pies made a big difference in the taste. Luckily, it turned out good. But in any event, again, testing code against small, non-realistic databases will lead to problems. Again, this goes back to you can extrapolate. Database optimizers, for example, will plan and execute SQL differently against a large database or a small database. If your database you're selecting against only has 100 records, then your query is probably going to give you a table scan, no matter what. Okay, even if there's an index that would fit, it's cheaper to use a table scan for that smaller number of records. Just sequentially search. On the other hand, if a real table would have 1 million records, okay, it's not going to table scan. Okay, the optimizer would pick something else, and you need to see that, but you won't by extrapolating. Okay. Size is not everything, however. The Mars Climate Orbiter. Okay, everybody familiar with that incident where the orbiter, this $1 billion satellite, whatever it was, crashed into the planet because the software which controlled the structures used the wrong units. So it underestimated the effect of the thrusters by a factor of 4.45. So the craft drifted off course at a much lower orbit than planned and was destroyed by atmospheric friction. Okay. So my point is here, everybody thinks, well, to do performance testing, all you got to do is beef up the data, right? And just blast out huge amounts of data, and that tests your performance. Nope. It's not just a question of raw data expansion. It's not just a question of sheer volume. It's a question of the exact nature of the data, and many subtle factors are critical to the amount of time it takes a given piece of code to execute. So the punchline of the case study here is we were testing a batch application, and in this case, one single row in one table caused a 25 increase in runtime in one environment versus another. This is internal trending testing, okay? Now, the presence of this single record drove business unit security code to happen just because it saw this record in there, okay? Just one record in one table. And that row had a value that was like an on-off switch that generated huge amounts of processing, okay? So performance problems might occur in small databases, but might be apt in larger databases. You got to get it right qualitatively as well as quantitatively. So a summary, performance is an overlooked and misunderstood genre in the area of software engineering. Hopefully these analogies will help you comprehend the issue and communicate these issues to your superiors, maybe those with less technical groundings, people that manage the efforts, etc. That being the case, every presentation like this I've ever given, internally to Oracle or externally, I'll always finish with the onyx. Where is the code spending its time? That's what performance is about. It's not about memorization or facts or whatever. So that being the case, any questions at all about anything in particular? Yes. The question was, am I involved with testing code prior to release? Yes, the answer is yes. That's part of what I do. The question was, do we have specific test plans that make sure each use case doesn't degrade from one release to the next? The answer is a resounding yes. We have a whole effort that we do regularly that we call trending. Okay, trending from one version to another, where we have a big effort, we install, version N and version N+1 on the same machine, hitting against the same database, other than the fact that the database sometimes changes between releases, so that's one of the factors that could affect things. Run the same use cases here, there. And we've got many, many scripts to do this, of which we have a core group of scripts that we call our day in the life, our DIL scripts. Day in the life because it's a suite of interactive and batch programs that are typical, that scope what our users typically use, even though there's not such a thing as a typical customer, but the answer is yes. Anything else? The question was, is it my impression that skills in this area are improving or declining? Well, you've got great organizations like CMG, right, that help them improve. I think the thing is, the direct answer to your question is, I think I try to make them improve. And when I have out on the Oracle website, up on our help site, I have about 40 presentations and recordings of these presentations. I give a once a month seminar that talks about one topic about performance. And over time, I see people putting these into practice. I do see less of the same type of questions, okay, when things are communicated in a way they can understand. So I guess in my sphere of info, the consultants that I work with, it's a small sampling, again, But I found, yes, when communicated in the proper way and when people are made to realize how important this is. I mean, analogies, things like performance is functionality. They call it non-functional, but a badly enough broken performing program is the same thing as a broken program, right? Like a payroll program that only pays one person per minute, right, but has to pay 10 million people in a week, do the math, okay? It doesn't matter, you may as well, it's the same thing as a broken program. Otherwise, you might say, okay, a million people in the company, let's see, which 1,000 people get paid this week? Unless that's acceptable, then that's a broken program. It may as well pay 1,000 people and then crash, right? Then what I find is, some of the higher ups say, yeah, you know, you're right, that's a good point. Maybe this performance thing is more important than I thought. So putting it in terms, taking the technical and making it, you know, non-technical, if you will, is the way I've had success. Anything else? Okay, but I bet you didn't know, just in case you don't know, that there will be a prize for the best evaluation. Words like genius, G-E-N-I-U-S, fantastic, you know. Just kidding about that. Make sure you fill out the evaluations. I'd like to thank CMG for giving me the opportunity to speak and share information.
Thanks, Chris. And on behalf of CMG, I'd like to thank you with a certificate to document our time together. Appreciate it all.
Is this a check or anything? It's not.
Yeah, we'll attach a drink ticket.
Oh, yeah, right, all right.
Thanks all. This is session 421 on your session evaluation. Thanks a lot.
Everybody see the movie The Grinch? Somebody